Hi guys, my name is Nguyễn Đức Thịnh. Now, I will present what are the main adaptations of the marine organism to deep sea conditions. To survive in the deep sea conditions, marine organisms need to overcome some challenges such as the salinity, thermoregulation, and pressure, osmotic and ionic regulation. Salt in seawater include not only sodium chloride but also other elements such as calcium, magnesium, and potassium. The substances get into the ocean through complex processes including volcanic eruption and hydrothermal vents, as well as less complex ways such as the wind and rocks on land, which dissolve into sand and then salts. The salinity of water has direct effect on marine organism survival. Adaptation enables organisms to maintain careful water and salt balance with their surrounding. Marine animals must also regulate the ingestion of freshwater and saltwater in their body, especially develop kidney wheels and body function help prevent the water from equalizing salt concentration of blood membrane through osmosis. For example, seabirds can drink salt water and they release the exhaust via the salt glands in the nasal cavities. Whales cannot drink much salt water. Instead, the water they need comes from whatever is stored in the breakways. They do have kidneys that can process extra salt. However, sea otters can drink salt water because their kidneys are adapted to process the salt. With some animals like fishes need a central concentration of salt to function best. They can just allow the water to diffuse filling through their gill. The saltwater fish would surface up and the freshwater fish would apply. In the case of freshwater fish, their blood and body fluids are much saltier than the water they swim in, so water will flow in through the gills. The opposite is true for saltwater fish. To stop the exploding fish phenomenon, their gill have special cells that selectively pump salt in or out of their blood. In freshwater fish, the cell contain pump salt in, and in saltwater fish, they constantly pump salt out. Saltwater fish kidneys also help to filter out some of their salt. Next, thermoregulation. Temperature affects animal metabolism. If the temperature increases, their processes increase and vice versa. So, body temperature needs to maintain. Many ocean animals, such as fishes, sharks, are cold-blooded, so their body temperature is the same as the surrounding environment. The rest are warm-blooded, so they need to keep their internal body temperature constant no matter the water temperature. Besides metabolism, temperature also impacts survival, distribution, feeding routes of marine organisms. Because temperature affects metabolism, if the rates of this process tend to increase, the growing rates of animal increase. Temperature controls the rates of fundamental biochemical processes in organisms and consequently changes in the environmental temperature can blow in population, special and community level process. The graphs show that fish will die at the low temperature, and at the slightly higher temperature fish can live, but they do not rise around very lowly, and at the center temperature, round will increase rapidly with increased temperature until the optimum temperature is reached. As temperature rises beyond the optimum temperature, rounds will low, sea and fish will die if the increase continues. Pressure increase rapidly with depth. Pressure increase 1 atmosphere for each 10 meters in depth. Most marine organisms lack long, compressible air pockets inside their body. Water-filled body exerts the same amount of pressure as a diffusing inward, so marine organisms do not feel the high pressure at depth. Without those air pockets in their body cavity, and these deep sea creatures are no longer susceptible to the same pressure that all body feels. Furthermore, while some creatures do have air in the echelon, and some even have sinuses in their head cavity, the tissues lining their cavity are often highly flexible and can readily expand, thus forcing out any air and preventing the pressure differential.